One of the biggest issues with additive systems that we looked at earlier is the representing multiples of a value. For example, 6 tens required using multiple symbols. For example, representing 60 in Egyptian hieroglyphs meant literally writing out 6 of the symbol for 10. Now, multiplicative systems improved on this a little by adding a multiplier. For example, 6 times 10 for 60 using the Chinese characters we discussed. A positional system goes that one better by letting the position of a digit within the number tell you what its multiplier is. One of the key features of a positional system is that every digit in a number actually has two pieces of information. First is its literal value, right? 5, 7, 9. And second, its position in the number tells you what its multiplier is. Right, for example, let's take a step back and look at an additive system like the Egyptian one that doesn't have this property. This number, looking at it, think of it, the Egyptian hieroglyphs, is 102. Right? This first symbol represents 100. And it represents 100 regardless of where it is in the number. So for example, if I just flipped it around and put it at the end, well, it still represents 100. So ultimately, these two numbers are equal to each other. This is not the case in a positional system like our modern decimal system. If I change the position of two numbers, like I did with the 1 and the 2 here, that changes the meaning of the number. Because the position of the two not only tells me that it's 2 units, it also tells me whether it's 2 units like we have in the first number or 200 units like we have in the second number. So let's take a look at an example here. If you just read the number 4,325, you can see the different multipliers in it, right? 4,325. There's 4,320, that's 2 tens, plus 5 making up this number. So to kind of make that more explicit, the way we would write this, I'm going to put the powers of 10 that are the multipliers under each number. I'll start with 10 to the 0, that's 1. 10 to the first, that's the tens. 10 squared is the hundreds. 10 cubed is the thousands. Again, 4 thousands, 320, or 2 tens, and 5. So to kind of build the number up, we multiply each of the digits by the value for its place. If you add all those up, you get the total quantity represented by the number. So if that all seems to be taking something that to most adults is pretty intuitive, you've been working with numbers your entire life, and turns it into something a little complicated, yeah, okay, I can see it. All right, but there really was a reason for all of that. I need you to kind of just put that in the back of your mind for a minute. When we start talking about numbers in bases other than 10, that idea of taking a digit times the power of the base, a digit times another power of the base, and adding them all up is going to come back and be really helpful in figuring out what exactly those numbers represent.